I've had some of you say I'm going faster than I did last year. Raise your hand if you agree. Okay, good. Glad to know I'm going faster because I need to go faster. Last year, if you remember right, we did not get through the curriculum. I need to go a little faster. You know, and if you guys know that it was probably pretty easy last year, wasn't it? Well, it wasn't much of an effort. We have an end of level test this year, okay? CRT at the end of the year that I have to get you ready for. In order to get you ready for it, I am going to have to move faster. Now, if I'm explaining something too fast and you need me to slow down on something, then do that because that part I don't want to go fast on. But if you're going to understand this, this is going to require time on your own studying. Do you understand that? Okay, and it's going to require homework time at home. So it's not going to be as easy as last year because I am going to need to go faster. Is the math going to be much harder? I don't think it's going to be much harder than last year. I just think that we're going to have to go at a faster pace. You're going to have to work a little harder, okay? Hope that doesn't scare any of you off. I'm going to try and do a better job of teaching this year. But once again, though, this is all new curriculum for me as far as the order things are taught in and combining different principles together. So it's really not going to be as fluid as I would like it to be. But, so you're going to have to bear with me there. But I do need to go a little bit faster to get us through this curriculum. I hope you understand that. The honors curriculum, not only do we need to finish the curriculum, but we have to do some extra stuff for honors. So I really need we need to move. So if I'm up here flying through a problem and you're not understanding it, that's the time to stop me and say, okay, I'm not understanding this. Okay? And I do that every once in a while. I don't mean to. So just be aware that we are going to have to go faster. And I know it's going to be painful for you, but we are going to have to be faster. You won't be able to read your novels during class this year, some of you. You're going to have to pay attention. You're going to have to take good notes. We're going to have those quizzes because I need you to know in the vocabulary and kind of know what's going on. So just be ready. Yes? Yeah, we can. Okay, on the other subject, right? Okay, number 9. Can I borrow this right here? Okay, number 9 on the circles assignment looks like this. You have 5 right here and 67.5 degrees right here. And you've got to solve this equation, okay? So I can figure out the other angle really easy. What do I do? Okay. All right. I know that these are complementary angles, right? So I can just subtract that and get that, right? What does that give me? 22.5? Oh, 22.5 degrees, okay? So we'll write it right here, 22.5 degrees. That part's easy. It seems that you guys are having a hard time with the sine, cosine, and tangent thing, okay? We got to go back to SOHCAHTOA. Maybe we didn't spend enough time on this last year. This was kind of rushed at the end of the year, I remember. I need to find, which side do you guys want to find? We'll call this one X and this one Y. Which side do you want to find? Okay, I've got to find X first. So I can use, which angle do you want to use, 22.5 or 67.5? Okay, if I use 67.5 and I want to find side X and I have the hypotenuse, okay, side X, is that opposite or adjacent to this angle? It's opposite. Adjacent means it would be next to it, right? And this one, Y is next to 67.5. So this hypotenuse is next to it, but it's called the hypotenuse. So the one that's next to our acute angle we're going from, that's not the hypotenuse, is called the adjacent. The other side is the opposite. So I need opposite side and hypotenuse from my angle. Which side is opposite and hypotenuse? Sine, right here. Sine is opposite and hypotenuse. You look at the last two, opposite, hypotenuse, right? So I have have sine of the angle I went from, which was 67.5 degrees. And it's equal to the opposite side, which is x, over the hypotenuse side, which is 5. Julie? It doesn't. Let me show you this. Julie just said, does it matter which angle I use? What if I wanted to use the 22.5 degree angle? Which side is x from the 22.5 degree angle? Adjacent. And I have hypotenuse. So which one is that? That one's the cosine. So I could do cosine of 22.5 degrees equals adjacent over hypotenuse. And I'm going to show you that these two give you the same answer. So what am I going to do to both sides of each of these equations to get x by itself? I'm going to times by 5. Over here, I times by 5, they cancel out. Okay, I times both sides by 5 here. Those cancel out. I want you guys to put both these in your calculator. 5 sine of 67.5 and 5 cosine of 22.5. And you should get the same answer, which is 4.62. Does everybody agree with that? Yes. Okay. How do you put in your calculator? Everybody make sure what mode do you need to be in? Degree mode. Check your calculator. If you're not in degree mode, check it and see if you're there. Now, in your notes, if this helped you understand it, write down what it helped you understand. Because when we have these little quizzes that I had the other day, we are going to, I'm going to take them from what you put in your notes. Okay? Okay, this is number what? 17? Okay, number 17 on that circle assignment. Okay. It gave you two formulas, the circumference formula, right? And the area formula of a circle. Okay, what was the first question that it asked me? UT up here? This arc? Okay. Now, you guys, what did it say about these lines? What did it do? What did these lines do to the circle? 6 equal parts, right? So each section is how much of the circle? 1/6. Each arc is how much of the circle? 1/6 of the circumference, right? So the inside, these pieces of pie right here are each 1/6 of the area of the circle. And this part is, each arc is 1/6 of the circumference of the circle. How many of you had that already? Knew that. Good job. Way to think of that. Okay, so the first question is to find length UT. Well, isn't UT an arc part of the circumference? So if I found the circumference and I divide it by 6, I'll have my answer, right? So I take the circumference, which is going to be, or in this case, it's going to be 2 times pi times the radius, which is 10. And that's going to give me 20 pi. And I really don't care which way you give the answer right here. I want 1/6 of that. So I'm going to divide by 6. So arc of UT, arc length of UT is equal to 20 pi divided by 6, which reduces to 10 pi over 3. Now, if you want to write that in decimal form, 10 times pi is going to be around 31.4 divided by 3 is going to be about 10.47. Okay? So that's going to be about 10.47 if you write it as a decimal. Does it say the measurement it was measured in, centimeters, inches? Okay. So then that is that arc length. Now after it said UT, where did it go to? The area of what? The area of one of them. Well, same thing, right? Area is equal to pi times radius squared, which is going to be 100 pi. 10 squared is 100. But we only want a sixth of it, so the area of one of those things is 100 divided by pi, times pi divided by 6, which is going to be 50 over 3, 50 pi over 3. Okay, which 52.36 about. And that's the area of one of those. Now, if you have to follow a path, what's the path it wants you to find? I'm going to trace it in green. What's the path? U to S. Okay, U to S, so it goes from here to here. How long is that, you guys? 10. Then where? And then to V from there? How long is that? Then where? V to W. How long is that? Wait, how long is this? 10.47. Then where? 2x. Another 10.47. Then what? Clear back to U, which is going to be 20. So another 10. Well, I'd like you to be with these about at least 100. So it doesn't take that long to add them in your calculator. So 10, the 20 plus 10 plus 10 is 30, plus 10 plus 10 is 50, plus 0.47, so it's going to be what, 50 point, oh, 60, I missed a 10 in there somewhere. 60.94. 60.94. If you've got 61, that's probably close enough. Do you understand the idea right there? Number 16 is the same. Okay. All right, this assignment's due. Okay. Here's the deal. We're going to pick 5 problems on there really quickly right now. I'm going to pick, how many problems were there totally? 17. Should I let the calculator do it? So we know it's random and not me being... I don't think my calculator's that random, but at least it's not biased. And I'm probably biased. Okay.
Hey, I have a question.
Yes.
If we leave it on degree mode, is that going to affect anything else?
No, not. The only time the only time the degree or radian mode affects it is when you're doing things in degrees and radians, like cosine, sines, tangents. So other than that, it's not going to hurt anything. How many did you guys say there were? 21? 17? Okay, we're going to do correct 9, 9, 1, 8, 6, 17. So 1, 6, 8, 1, 6, 8, 9, and 17. 1, 6, 8, 9, and 17. Everybody pass your paper. Trade it with your shoulder partner or someone else. Someone nearby. Trade your paper. Here we go. Okay, you guys. We are supposed to find the length of the pendulum, given that it takes 1.5 seconds for it to swing, the pendulum swing over and back. Okay. So, what variable do I have to solve for here? I've got to solve for L. What variable do I know what the value of it is? Seconds. What is it? 1.5. So I'm going to plug in 1.5 equals 2 pi times the root of L over 32. Now, what kind of an equation do we have? I have a radical equation, don't I? Just what we've been learning. Why do I have a radical equation? What makes it a radical equation? The variable inside the radical. So how do I solve this? What am I going to do first? I've got to isolate the radical. So I've got to do what to both sides? Divide by 2 pi. Those cancel out. I get 1.5 divided by 2 pi equals the square root of L over 32. Now, maybe for the sake of making it easier, let's calculate that. What's 1.5 divided by 2 pi? Make sure you put parentheses around the 2 pi, just to make sure it does it right. Put parentheses around 2 pi when you put it in your calculator. Tell me what you get. 0.23, let's take it out to 4 decimals. 87. 0.2387. Keep in mind, this is a small number, so we need to take it out at least a little ways, 4 decimals, to make sure our answer is accurate, right? Okay, so right here, now I have, how do I undo the radical? Square both sides. So we're going to square both sides here. What happens when you square this? Point what? 0.5699? Like that? Equals L over 32, because we undid the square root, right? And the last thing you're going to do is what? Times by 32. And what does it equal? So we could probably round that answer now because it's the length of a pendulum in, well, in feet, if we wanted to. So 1.24 feet. 1.24 feet. 1.8237. So we could round it to 1.82 or so feet. Pendulum of 1.82 feet. So how many seconds does it take that pendulum to go back? 1.5 seconds, right? And how long is that pendulum about? Somewhere around in there. Does that look about 1.8 feet?
No, it's not so long. It's like
not at 1 foot. It's almost 2 feet. It's 1.8 feet. It's almost 2 feet, isn't it? Yeah. Those are cool. Okay. Because this one is going to require you to FOIL, isn't it? Because not everything's inside the square roots on both sides. There's not a single square root on both sides. So, because you have, on the right side, you have the square root of 4z minus 2, but you also have a plus 3, right? So, when I square both sides right here, I'm going to have to FOIL the right side, right? So I'm going to get 4z plus 1 because squaring the left side undoes the square root. On the right side, I'm going to have to FOIL. So I'm going to write this down. 3 plus square root of 4z minus 2 times 3 plus the square root of 4z minus 2. Did I write that down right? It is 4z minus 2. Is that correct? In your book? Okay. And if I FOIL this, I'm going to go 3 times 3 is 9. 3 times that is going to be 3 square root of 4z minus 2. Then I'm going to have another one of those. So I'm going to times that by that, and I'm going to have plus 3 times square root of 4z minus 2. And then I'm going to have a 4z minus 2, the square root of 4z minus 2 times the square root of 4z minus 2, which is just going to leave me with 4z minus 2. Got it? Am I going too fast? Okay. All right. Okay, so right here, you guys, we have like terms, don't we? Should we combine all like terms? Anything like 9? Minus 2, so I get 7. Anything like this, the second term? So I'm going to have 6 square root of 4z minus 2, because I can combine those two terms. That's all one term, isn't it? Plus a 4z. Now, what's the next goal right here? What do I have to try to do now? Well, I need to get the square root thing by itself, don't I? I have to isolate the square root thing. Everybody write that down. Get the square root part by itself, isolate it, because then it allows us to square again and get rid of all our radicals. So I have to get rid of that radical. So what am I going to do to both sides here? minus 4z, and what else? That works out kind of nice, doesn't it? And minus 7? Okay, the 4z's add up to 0, so I have negative 6 equals 6 times the square root of 4z minus 2. Do I have the square root by itself yet? No, I'm down to one term, but the square root of 6 is being times by the 4z minus square root 2. So what am I going to do? I'm going to divide by, I got to divide by 6. And I'm going to get negative 1 equals the square root of 4z minus 2. Now I have a radical where I can get rid of it because it's isolated. What can I do to both sides, everybody? Square it. You know why you get extraneous solutions sometimes doing this, you guys? Because look what I'm going to square over here. A negative 1. And that's going to make it a positive 1, right? So I'm going to get 1 equals 4z minus 2. It probably changed the answer. It might be extraneous now. Add 2 to both sides. What do you get? 3 equals 4z. Divide by 4. What do you get? Z equals 3/4. Got it? Z equals 3/4. Now we got to check to see if it's extraneous, don't we? Because we had square roots on both sides. Okay, so if I go back up here to the very top, and I plug in 3/4 for that, 4 times 3/4 is what? 3. Because the 4's will cancel out. 3 plus 1 is 4. The square root of 4 is 2. So my left side is 2. Once again, over on this side, 4 times 3/4 is 3. Minus 2 is 1. The square root of 1 is 1. 3 plus 1 is 4. Is 2 equal to 4? So this answer is extraneous. I have never seen one, but that's a good question. 14. Let's look at 14. You know what? Actually, I take that back. If you get one side to be negative like that, yes, then it can be. That's because that's the same problem we ran into right here, wasn't it? Okay. So like on number 14, you guys, 14 is extraneous, but I want you guys to show me why. Okay. Okay, this assignment, Zach, when's this assignment due? Okay, it's due on Wednesday. No, not Wednesday. Tuesday. It's due on Tuesday. Okay? Tuesday. Okay, so the 4 inequality problems at the end, we are not going to do those. Okay? Right now, so you can delete those off there. Okay, what I'd like you to do right now, you guys, I want to see who can solve this equation. We're going to do it in groups right now. So, who's sitting right there? Oh, yeah, Taylor. I want, Julie, will you move back a seat, your seat, and then you 3 work together on this? Taylor, Andrea, and Julie. Which numbers are the inequalities that we're deleting, you guys? 31 and 34? 31 through 34. Okay. If you see them, tell them. But I just said it on this video, so if they're not listening, that's their fault. I told them to listen. Okay. Let's see how many of you guys can solve this equation with your partner. I'm going to give you about 2 minutes. Go. You guys, Cheyenne's going to tell us what she did to get this. Okay, listen up. Shh. Okay, go ahead, Cheyenne. You times both sides by 28/9. Come up here and write it down. Write it down off to the side a little bit over here. Okay. Yeah. So, okay, Cheyenne's doing this. She times by the reciprocal.
Oh, yeah. Forgot about that.
You could have just.
I remember that. So that's when you do cos. Okay, I got it. I understand.
Why would you times them? I know that's
Okay, that's interesting. Okay, I would have to say that you missed something, and I think it might be by coincidence that you got that answer. Because look, order of operation, if you times this whole side by 9/28, because you have to distribute the 28/9, right? And when you do that, this cancels out, but it's still what? 1. You should have a 1 out there. And and it's just no, it's not gone. It's 1 because 9 divided by 9 is 1. 28 divided by 28 is 1. But I want to know how the z plus 2 got on top. Okay, I'm looking at this. Maybe I'm missing something you did, but why did you times this by 3? Okay. All right, let's see another way you did it, okay? Let's see someone else do it. Okay? Okay, JD's going to write down what he got. Well, that would be great if it worked every time like that, but it worked. It worked. Okay, keep going, JD. Keep going. Keep going. He can minus 9/28 from both sides. Wait, you did what? Okay, so he made the common denominator, so he gets 21/9. Okay, so rewrite the whole problem down there. Okay. Okay, hold on. Back up for a second, JD. JD is actually using a correct method right here. This is working. I want to make sure you guys understand what he did. He took 9/28. Technically, that should be a plus right there. Put a plus. Okay. So he's minus, yeah, but still put 1 there. So he added a negative 9/28 to both sides, right? Or you can think of subtracting 9/28 from both sides. And that got rid of the 9/28 over there. And so over here he had 3/4 minus 9/28. He got a common denominator, subtracted. He came up with 3/7 right here. So now on the left side he has 3 over z plus 2. On the right side he has 3/7. Okay, go ahead and finish. So he's timesing both sides by z plus 2. Keep going. Now, don't you need to put parentheses around the z plus 2? Because it really is timesing by the whole thing, right? Okay. actually, you times by 7/3. So he divided 7/3 into both, or 3/7 into both sides, you guys, which is the same thing as timesing by 7/3, right? Typical multiply. And so z equals 5. Write it down. This is a correct method, although it's not the fastest way to do it, but that's a good method. Did you just were you just skipping some steps in your mind? You might have. I just couldn't follow it, what you're doing. Okay. All right. Hey, we guys, good. And you probably did, Cheyenne. If you skip some steps. Well, yes, but you got to make sure that that process works for every type of problem. Okay. So this is how. By the way, what kind of equation is this, everybody? Okay, everybody write this down. These are rational equations. What makes an equation a rational equation? When what? What does a rational number mean? Yeah, it usually what does ratio mean? Yeah, it means a fraction, right? And it usually means that there's a fraction in the problem. So, and a lot of times, that in the bottom of the fraction is a variable. Do we have a variable in the bottom of the fraction? In order to solve this, we have to get the variable out of the bottom, and we have to get it on the top. And JD used the correct method, and he did a correct method. It's just we can shorten it a little bit, okay? Both of you, and Alyssa, okay? So we can shorten this a little bit. So if you look right here, this is the idea behind solving rational equations. Maybe I'll move this up so you can see it. Okay, the idea is to multiply both sides of the equation by the LCD to get rid of the denominators. What is an LCD? You guys all learned it. Okay, Julie, say that again. Andrea. Lowest common denominator or least common denominator, we use both ways. Okay, the lowest common denominator. Now, it actually doesn't have to be the lowest common denominator. It can be any common denominator. However, you work with smaller numbers when you get the lowest common denominator or least common denominator. So what we're going to do, I'm going to show you another method. I kind of liked the fact on this one that JD got all the terms that didn't have a variable in it on one side first, because it actually makes it faster that way. But then I'm going to show you a faster way to finish it off at the end. Okay? The idea is to multiply both sides of the equation by the lowest common denominator to get rid of the denominators. Are we okay? Okay, here we go. What I'm going to do, I liked, you know what? I'm going to show you another way to do it, just because not all the time is it going to be where, but I mean where this number right here, 9/28, doesn't have a variable in it. So I'm going to show you a different method. Okay, the lowest common denominator, you can get a common denominator by multiplying all the denominators together, and that would work. The only thing is 28 breaks that down into 4 times 7, and 4 breaks down into 2 times 2. So this breaks, the prime factorization of this is 2 times 2 times 7. And 4 breaks down into 2 times 2. And z is already factored. It's the lowest it can get, okay? And so what you do is you take every factor the least number of times it takes place, but you only take it once. So all I need is a pair of 2's, a 7, and the z plus 2. That's the least common denominator. Okay, I don't need this other pair of 2's over here. I can leave them out. And so the least common denominator, if I times these numbers back together, 2 times 2 times 7 is 28. So my least common denominator is 28 times z plus 2. 28 times z plus 2 is my least common denominator. So everybody write up here, least common denominator is, or lowest common denominator, 28 times z plus 2. I took the prime factorization of 28, which is 2 times 2 times 7. And I took the prime factorization of 4, which is 2 times 2. The least, or the lowest common denominator would be each factor, each set of factors, the least number of times it occurs, okay? So 2 times 2 happens twice here, and it happens twice here, but I don't need to, since it happens here and here, I only need to take it once, okay? 7 happens only once here, but nowhere else, so we got to take it. Z plus 2 happens only once here, so we have to take it. So I have to take 2 times 2 times 7 and z plus 2. 2 times 2 times 7 is 28. Okay, but I don't have to take that other 2 times 2 because I already got a 2 times 2 right here.
Wait, so that was like...
Then you just multiply every number together, and that would be your least common denominator. We'll do some other problems like that. You know, the problem with solving these equations right now is you guys are supposed to have already learned how to do least common denominators, and you have. You probably just forgot. So we'll come back and work on those. So what I'm going to do is times both sides of this equation by the lowest common denominator. So I'm going to times 9/28 by the least common denominator. So I'm going to go 28 times z plus 2 times 9/28. And I'm going to, because I have to distribute it, I've got to times this one by the least common denominator. I'm going to times 28 times z plus 2 times this fraction, 3 over z plus 2. Equals, I'm going to move over here. Okay, and then I have to times the right side, which is the 3/4 by 28 times z plus 2 times the 3/4. It's on the right side. Now, it kind of makes it long, but at this point, I can cancel out a lot of stuff, can't I? Look over this first set that I drew. What cancels out in this first set? 28s. What cancels out in the second set? Z plus 2s. What cancels out in this one? 4 will go into 28 7 times. Notice that all my denominators are gone. And what happens when you times a rational equation by the least or the lowest common denominator is that all the denominators disappear. They're gone. Well, 4 is on the bottom. 4 will divide into 28 7 times. So I'm left with 9 times z plus 2. If I distribute, I get 9z plus 18. Over here, I'm left with 28 times 3. What's that? $84. And on the right side, I'm left with 21 times z plus 2, right? Because 3 times 7 is 21. So 21 times z is 21z, and 21 times 2 is 42. Now I have an equation that you guys know how to solve, right? Okay. So now I can minus 42 from both sides. Oh, you know what? Yeah, let's do that. Minus 42 from both sides. And I can minus 9z from both sides. And I'll have all the z's on the right side and all the constants on the left side. What are all the constants here? If I combine like terms, 18 plus 84 minus 42. 60 exactly. And on the right side, 21z minus 9z is 12z. And 12 will go into 60 how many times? I actually think the reason I showed you this method, you guys, is because even though I think JD's method is faster, because sometimes you're going to have variables in both of them, and I need you to see this method, and you have to do it this way. But I like JD's method. I want to show you again JD's method, but I can make it a little bit faster. After we minus the 9/28 from both sides, since 9/28 doesn't have a z in it, you're going to end up with, let's rewrite this on the other page. 3 over z plus 2, and what did it reduce to? 3/7. So 3 over z plus 2, 3 over z plus 2 equals 3/7. I want to show you this kind of problem. Because, by the way, what's the least common denominator right here, or lowest common denominator here? 7 times z plus 2. A lot of times, that's all you have to do. If I times both sides by 7 times z plus 2, 7 times z plus 2 times 3 over z plus 2, and 7 times z plus 2 times 3/7. See, all I did is I'm timesing both sides by 7 times z plus 2. Whatever you do to one side of the equation, you do to the other, right? That's why I can do this.
Wait, that would be faster.
Well, we cancel those out. We get 21 over here. Cancel those out, and I get 3z plus 6 over here, and then I can just solve that equation. But it's the same as cross multiplying. Here's the fast way. Anytime you have a single fraction on the left side and a single fraction on the right side, all you have to do is cross multiply. 3 times 7 is 21. 3 times z plus 2 is 3z plus 6. I get the same thing, right? Really fast. That's why I'm telling you. That's why I wanted to show you that method. Wanted to show you it's the same thing as timesing both. Anytime you have one fraction on the left side and one fraction on the right side, all you have to do is cross multiply to get rid of the denominators. It's a fast way to do it, but it only works when? When does it work? One on each side, one fraction on each side. You can't do it when you have two fractions like this. So that's why his method worked fast, is because if you minus the 9/28 from both sides, since they'll combine into a single fraction on the right side, then you can just cross multiply and be done. Okay? All right. I would like you guys to solve this problem. This is kind of similar to the one we just did. I'm going to take a few minutes and solve it. Okay, so if we use JD's method of minusing 7/12 from both sides, so I'm going to get 9 over x minus 4 equals, and if I get a common denominator here, this is easy common denominator to get. What is it? What's the common denominator, 48 and 12? 48. So I'm going to get 55 over 48 minus, if I times 12 by what? 4. I'll get 48 over here, which means I have to times the top by 4, which I'll get 28. And if I go 55 minus 28, what do you get? 27. So I get 27 over 48. So that part was JD's method. Then I showed you guys how to cross multiply when you have a single fraction on each side. And then all you have to do, what's 9 times 48, you guys? 432. And 27x, if I times 27 times x minus 4 distribute, 27x minus what? 108. Okay, and then we know how to solve that. Add 108 to both sides. What do you get? So we get 540 equals 27x, and I already know that 27 goes into 54 twice, so it will go into 540 20 times. And so there's your answer. What? So is it a little shorter? Okay. Sometimes I know tricks, but I didn't even think of doing that problem that way at first, but it makes sense to do the minus 7/12 from both sides first. Makes it shorter. Sure. Okay, well. Okay. Okay, do we have this one, you guys? Now, they get more complicated. Okay? For the sake of time, I'm going to show you this one really quickly. R squared minus 1 factors. Does anybody know what a factor is to be? R minus 1 times R plus 1. That's correct, Cameron. Good job. That factors. Notice you also have an R plus 1 right here. And over here, this one right here is just 1, right? So my greatest common factor is, or my least common denominator is, or lowest common denominator is, R minus 1 times R plus 1. Okay, so I've got to times, so what I'm going to do now is I'm going to take this R right here, and what am I going to times it by? R minus 1 times R plus 1. Plus, that's this plus sign right here, you guys. Plus, I've got to take R squared minus 5 and times it by, I got to take R squared minus 5 over R squared minus 1 and times it by my common denominator, R squared minus 5 over R squared minus 1 and times it by my common denominator, which is R minus 1 times R plus 1. Nice thing about that is what's going to happen? R squared minus 1 cancels with R minus 1 times R plus 1. Okay, and then I got to times this one over here, the R squared plus R plus 2 all over R plus 1. I've got to times it by the R plus 1 times R minus 1, right? Okay, let's cancel everything out. Does anything cancel out on the first one? No, but I'm going to have to multiply this all out to solve this problem. I'm going to multiply the two binomials together first and then times R by it, distribute an R through. Oh, we already know what that is. It's R squared minus 1, right? And if I times an R by it, it's going to be R cubed minus R. Okay, over here, these cancel out with those. So I'm just left with an R squared minus 5. And over here, the R plus 1s cancel out. So I'm left with an R squared plus R plus 2 times an R minus 1. R squared plus R plus 2 times an R minus 1. I've got to multiply the right side out and the left side out. The R plus 1s. The R plus 1 and R minus 1, that's my common denominator. My least common denominator was R plus 1 times R minus 1. So I times everything by R plus 1 times R minus 1. Now, you guys, this equation is going to be there's going to be a cube on both sides. I believe the cubes will cancel out. Yes, they will. Because you're going to have an R cubed on both sides. If you minus R cubed from both sides, you're going to get 0 for that. It might end up being a quadratic equation. So you'd have to get everything to one side and solve it as a quadratic equation. Okay, they get more difficult. Okay, here is your assignment. Keep in mind, we'll work on this again next time, but I want you to try and do as many of those problems as you can. Try and do as many of those problems as you can. So 10 through 17 all, 12, 24, 25, and 33. So when will this assignment be due? Thursday. So on Tuesday, we will go over more of this. Okay? Tuesday, we'll go over more of this.